So how much is 0.18? 0.26. Okay, just a minute. 0.18 and 0.34 was their next data, right? How much is there in how much is G by RT x1 x2? Second data set. 0.375. Next one. 0.4107, 0.4244, 0.4804, and the last one is 0.5314. Okay. So I think this problem was given in YBC now. Did you check it out? Okay. So look at this kind of problems in YBC now. So this type of problems are there. So now I can tell you the Smith Banach, YBC now, and Sandler's book will be very handy because a lot of example problems are given. Of course, the theory there has some kind of difficulty, but a lot of numerical problems you can consult those books. Okay. So the question comes, how to fit? So we have G by RT x1 x2 by x1. Data sets are okay. So data sets are actually given, and what actually happens? This is straight line behavior from the model. The thing is that for the straight, because the data, expected data, what you actually have, the PXY diagram, the expected data, and expected uncertainty will be there. So looks like it may not be straight line, this data, it will be like curve. And if you want to draw something, you are completely gone. So you have to go for the least square. Least square means you have to look for this kind of fitting, y equals to ax plus b. The question is the exam. We don't have computers. You have to get A and B. How to get A and B? That's the question. Computers means you can go to Excel sheet. You go for least square. It will be done in 1 minute. Excel sheet is fine, but you have to know the basics. How to get do the least square analysis? How to do least square analysis? How to get A and B? So basically, what actually happens? If you, I don't remember the formula. I don't remember the formula like you guys. Even I don't know how much you remember the formula. These are the data. This is my error. PI. I have data. See, that is the way I derive the formula. I have data. This line equation is AX plus B. Depending on this A and B means by changing that, A means shifting this line. If you shift this line, your A will change. If you do like that, B will change. If you do this kind of behavior, then automatically you have to find out where the summation EI square is minimized. Summation EI square. What is summation EI square? EI is nothing but error. Actual data is YI. From fitting minus AXI plus BI. Right? So my error is summation YI minus A minus BXI whole square. This data is YI. This coordinate is, this point coordinate is XI, YI. So if you put in this equation AXI, you will get to this line. This is Y, this is AXI plus B. So error is YI minus AXI minus B. Right? That is the way. I don't remember the formula. So my two unknowns are A and B. So you have to change. So that means if your objective function, say called capital E, you have to put dou E by dou A equals to 0. Optimization. That's what we have done. That's optimization, bro. What we have done. Dou E by dou A equals to 0. Dou E by dou B equals to 0. So if you set it, what do you get? What do you get? If you set, what do you get? Dou E by dou A equals to 0. What do you get? What equation? And dou E by dou B equals to what equation you get? From there you can get the answer. Dou E by dou A equals to 0. What will you get? I am asking for derivative. I can tell you that this thing I did in 10 plus 2. I had a course called statistics. I didn't take biology. I had physics, chemistry, mathematics and statistics. In my statistics, I did the first time derivation at 10 plus 2. So I am asking actually the same thing, an MTech level. So what I could do in 10 plus 2. And that time I learned such a way, I don't even forget. Even the same recap, actually I can do it here. But I am surprised that what I did in 10 plus 2, I am not able to get it. Derivative part. You told some formula the one, right? I don't remember the formula. I don't remember. If I remember, that's it. I cannot teach in the class. I have to know the philosophical perspective, right? And I don't know how we learn it. Maybe difficult to learn, right? Yes. Your face looks that way. The same derivative I am not expecting. I am expecting but not getting. What is that? Anybody can get it? Derivative part? Yes, sir. Good. Tell me.
Minus 2.
Minus
2.
Minus 2. Okay, minus. Why minus 2? Because of this minus 1? Yeah. So it is minus 2 equals something will be 0, right? So yi minus a minus bxi equals to 0. So minus 2 doesn't matter because it is going that side. So it is nothing but summation yi equals to na plus b summation xi. Right? Similarly, dou e by dou b. Now you should be doing fast. Dou e by dou b. Who can do that? Tell me.
Minus xi into yi minus.
Not minus. If you can directly say that xi into yi minus a minus bxi equals to 0. It gives summation xi yi equals to na plus summation xi a summation xi plus b summation xi square. Now that's two equations, two unknowns. Do grammar school. What is the unknown? A, B vector. Okay. So first is n, second is summation xi. Then here summation xi square. Right hand side is summation yi, summation xi yi. Okay. Similarly, if you have multiple, if you want to treat the curve, this is a1 plus a2x plus a3x cube. The same way you can do and you can get 3 by 3 matrix or 3 unknown. So this is the way, without having the plots in a graph paper, we can calculate a and b from that. And from there, we can get the exact values for the model. So once you go back home, you will see that. So what I actually got, you can also verify GE by RT x1 x2, which is 0.555 x1 plus 0.315 x2. Actually, the function what we got with respect to x1, which is 0.315 plus 0.240 x1. Verify from the least square. Whatever data you actually have, you can verify. So what did you get? You get this is your y and this is your x. So in a table we have G by RT x1 x2 experimental data. Here you have x1. This is called your y. This is your x, right? Then summation xi. We can have summation xi, yi. You can have summation xi square. You can have. All those values we have to get it, and then from there we can actually get A and B. So this can be doable, and this may be one of the questions in exam. So please do it by least square. I now have understood what is least square from this, and even if you forget the formula, if you know the basics, even sometimes I will say that fit a quadratic curve. For a quadratic curve, it is also doable, 3 by 3 system. So from the least square, you can get the quadratic formula as well. Okay. So then finally you have to calculate the theoretical value of y. What was the question? Compare the experimental data with that calculated from modulus equation. Okay. So you got the final formula. So final formula is final formula is G by RT x1 x2, which is 0.315 0.240 x1. Okay. And with that, so your 3 suffix modulus equation, if you remember, your activity coefficient theoretical modulus, then gamma 1 is x2 square into a12 plus 2 into a11, sorry, a21, a12 x1. Similarly, you can get ln gamma 2. So at x1 equals to 0.017, at past data, at x1 equals to 0.087. Ln gamma 1 into how much? Or gamma 1 into how much? Can you calculate and tell me the answer? The value of a12 we have got, right? How much is value of a12 and a21? How much is the value of a12 and a21? Can you tell me? So before calculating, so it should not be have to the wrong values. I have given how much is a12 and how much is a21. I have given everything. a12 and a21, how much value you put? Let's see if you follow it on the board. a12 is how much?
A12 is 0.315.
And a21? 1,555. Remember that is 0.315. You have to calculate in terms of x1, x2. And that's what I have given the formula here. It is there. So now get me ln gamma 1, that is get me gamma 1. Get me gamma 1 first and then gamma 2. And then we will see how we will calculate the theoretical values. You have to calculate theoretical y1, yi's, and you have to compare with exponent data. You have to compare with the exponent data. You have to compare with the exponent data. Okay, how much you got? Gamma y? Gamma 1? 1.3463. Gamma 2? Gamma 2? The formula is there. The gamma 2 for ln gamma 2 is nothing but x1 square into a21 plus 2 into a12 minus a21 x2. If you put the formula, what did you get? Gamma 2 1.0009, right? Okay. So once you got it, you have to calculate pressure. Calculate P. What is P? Summation yi. Sorry. Yip equals to gamma I xi pi sat modified Gauss law. Yip equals nothing but gamma xi pi sat. Okay. So what is y1? And summation yip is nothing but this, and this is equals to P. So what is P? How much is P? Calculate P. Once you calculate the P, you can get y1. Once you calculate P, your y1 is what? Gamma 1 x1 p1 sat by P. So you need to calculate P. You need to calculate P. P1 sat, P2 sat were known yesterday. You have done by Antoine equation. Look at Antoine equation. Get P1 sat, P2 sat. Do the Antoine equation. Get P1 sat, P2 sat. Gamma 1, gamma 2 are given. You need the summation part here. Gamma 1 is there, gamma 2 are there. You put the memory function in the calculator. Get me the answer. Very fast you can get the answer. What's the P? Pardon? There is no unit of P. What are you talking about? P. Pressure is 0.1925. Are you mad or what? To 238.20 torque. 238.20 torque pressure. Please tell the units. Then Y1 is how much? It's coming 0.1925. What you are talking, I think maybe Y1. So you calculate directly everything. So that's the one data. So like that you can actually get all the data. So we don't need any graph paper. We need to only know least square analysis. Based on the data, you can do least square, you can fit it, and you can solve the problem. Okay, so you can have the entire comparison. We'll move to the next problem. So next, before getting to the next problem, I will try to show the logistics on the TXY diagram, because TXY diagram is slightly different from the PXY. PXY doesn't require the trial and error solution or reduction method kind of solution. Here for TXY diagram, this is bubble temperature, due temperature calculation. You need to have the iterative solution. So let's look at how we proceed the similar way of the PXY. Again, we want to recap. Remember that there are a whole lot of problems in Smith bandless and all the books, so you can actually practice. So for this type of situation, generally really is considered to be a very easy part of the thermodynamics. So lot of example problems are available here and there. That's why I'm not discussing much. I'm just discussing selling points. So compute TXY diagram and compare with experimental data and compare with experimental data. First step, calculate the saturation pressure PI sat of the experiment of the components at the experimentally determined temperature, at the experimentally determined temperature. Second step is calculate gamma I. Second step is calculate gamma I from experimental values of PTI, XI and YI. And what we have done in our gamma, calculate gamma I from experimental values is YIP by XI PI sat. What we did last problem. For each data point, we have the next step is you have the next step with you. Because if I tell everything, then you won't understand. Next step is what? G by RT equals to G by RT is summation XI. Okay. And then choose model. So this will give, so this step, from this step what you get? G by RT, some x1, x2, whatever, you get the data. Now it comes to the model. Okay? So from the model, and then from there, we can calculate, once the model has been done, we can calculate 1 by RT, dou G by dou Ni, PT, Nj. Once the model has been done. And after that, you calculate the pressure, calculate the Y. Okay? But here is the equation process. Here is the equation process. What's the equation process? Choose some arbitrary values of xi in the range 0 less than xi less than equals to 1 for each values of xi, for each values of xi solve gamma I equals to yit by xi pi sat, and obtain values y and t, and then do the iteration process. And notice whatever values you get yi, remember that you have to check summation y equals to 1 on 1. If you are not getting that, means your yi's are not correct. These checkings are not done before, but here it is changing. You have to do the temperature. So to guess the temperature, get the yi values, because depending on temperature, your pi sat will change. Right? And once the pi sat will change, your entire thing will be changed. This is very important. So when you get the gamma is smaller from particular temperature, you have to calculate the yi. Summation y has to be 1. If summation y is not 1, we change the stuff and proceed further. So next problem number 4, I guess, of the problem sheet 4. I have given problem sheet 5 yesterday, so it is xeroxing is over. Yeah, okay, then give me afterwards. The following isobaric Beery data for the system methanol and nitromethane at 760 torr has been experimentally determined. Determine the parameters of the Van Law equation. So there actually this problem is different slightly. It is not Christophilus-Margulis equation. It is Van Law equation for the system. Number 2, calculate TXY data for the system at 760 torr pressure from the Van Law parameters and compare the results of experimental data. That's the same problem, but it's a TXY system. Okay. So Antoine constants, everything is given. So what we will proceed? Calculate the pi sat. Same steps. So far the same steps. So we will start with calculation of pi sat. Start calculating the pi sat. First data is 96.9 degree. First data 96.9 centigrade, right? How many data set are there? 4. 96.9, 68.2, 65.1, 64.5, right? 4 data set are there. First data set. So we have Ti, Tx1, Y1. Then we get P1 sat, P2 sat. We won't write it, we write gamma s. Right? What are gamma 1, gamma 2? At 96.9, you can calculate P1 sat and P2 sat. P1 sat is how much? P1 sat, P2 sat? P1 sat, P2 sat. Yes, P1 sat, P2 sat, I am waiting for. The same problem, this should not be taking so much of time because everything is given. A, B, C, temperature, both all are given. Gamma 1, gamma 2 is next. But what is P1 sat, P2 sat? Yes? 2402.1 torr. 2402.1 torr. And P2 sat is 664.8 torr. So now I will be asking for gamma 1, gamma 2 experimental, which is Y1P divided by X1 P1 sat. x1, y1 data are given. Exponent data are given. x1, y1. p1 sat is also there. P is given 760 torque. So should not be having any problem to get gamma 1. ln gamma 1 you can directly get. Let me get ln gamma 1, ln gamma 2. We need ln gamma 1, ln gamma 2 for G by RT. Right? We have to get G experimental values of G by RT. Right? What is ln gamma 1? What is ln gamma 1? If you don't have ln gamma 1, it can be gamma 1. Whatever way you feel like. Gamma 1 is how much? 2.8053. Gamma 2 is? Gamma 2 is? Gamma 2? Pardon? 1.0063. ln gamma 1 and gamma 2. Just put long. So it is nothing but 1.0315 and second one is 0.0063. G by RT value might have got summation xi ln gamma y, which is 0.0217. Did you get it? x1 ln gamma 1 plus x2 ln gamma 2. Okay. So now if we look at the Van Laar equation, what is Van Laar equation? So G by RT equals to AX1 X2 by X1 into A by B plus X2. Am I correct? Van Laar, we have done already. How the fittings will be? How to estimate parameter A and B? That these questions are actually asked by Avijit Nag and all, right? You asked how to estimate. So whatever you asked, I will give you the answer. Now tell me the answer from this data how to get A and B. I want to fit Van Laar equation. How to do that? I want to fit Van Laar equation. How to estimate? 3 suffix modulus equation was very easy. You put x1, x2 there, you got the linear part, you got it. But if you want to have RT x1 x2 divided by GE, okay, should be equals to then replace x2 by 1 minus x1. Okay, they replace x1 by 1 by x2 by 1 minus x1. So we have the graph for RT x1 x2 GE. You have x1 and you have the line and the intercept is 1 by A and this is intercept will be 1 by B, right? Intercept will be 1 by A, 1 by B. So then we have to arrange the data. So you have to plot. You have to get data RT x1. So the G by RT is given already. From this G by RT is given. Take the reciprocal, you get RT by GE. Multiply by x1, x2, you get the proper data. Okay? Linear. Like y equals to x plus b. As I discussed previous problem. Do least square. If you do least square, you get theoretical predictions A and B. From theoretical predictions, you get the theoretical values of y. And that's the way your TXY or PXY diagram. So that's the way. The advantage of this data is, so you have got only 4 data, right? If you want to draw your diagram, that TXY is a diagram, right? TXY. With 4 data, you won't get smooth data, smooth diagram. The data will be somewhere here, somewhere there. But in your theoretical predictions, what you can do, you can have your theoretical table. You can have xi, yi. You can start point 1, point 2, point 3, you get theoretical values. Right? How to get theoretical values? We have done it. But thing is that You have to fix the temperature. So for that particular temperature, you got a temperature. For this case, what's the temperature?
96.9.
Pardon, how much? 96.9 degrees centigrade, yes. So from here fitting, I give you the values, what values actually I got. I think this type of problems, unless you do yourself, you cannot appreciate, and I cannot do in the class. You have to go home and practice, and then get back to me in the class that I have done it. Yesterday I have discussed, I don't think anybody has done the class. Have you done with the least square? Have you got the answer? Yeah, don't not the head. Even if you say I didn't do it, I won't beat you up.
I have done it by graphical method.
That's what. In the exam, graphical method. You are fooling me. Don't kid me. You can do graphical method. Can you show this correct? Of course not.
So the value will
Of course not. Graphical method cannot give least square. Least square needs the calculation unless you have a computer. You can do graphs, you can do anything, but you have to decide what is correct or wrong, right? Graphical method is just like eye estimation. I don't care. And with eye you don't know which is correct or wrong, right? In fact, I will say that for this case, least square is very easy to do. Graphs will take some time. If you have a calculator, you can directly find out A and B with the data. Okay, so for this problem, we have A equals to 1.487 and B equals to 1.408. Okay, so please go back and check, verify it. And thing is that we have to calculate the y1. Okay, for that purpose, we have to calculate the y1. So assume T equals to 95 degrees centigrade. Assume T equals to 95 degrees centigrade. We calculate y1 and y2. Calculate y1, calculate y2. Summation yi equals to 1. Earlier what actually happens, previous problem, if you look at temperature of the fixed system, pressure was changing. Now temperature is changing. Expected values of temperature may not be correct. You have to correct it based on the theoretical predictions you assume. So it is given 96.9, right? Your temperature, that may not be the correct temperature. So assume temperature 95 degrees centigrade. What you will get? Y1 is nothing but x1 gamma I, gamma on x1, P1 sat by P. P is fixed, celestial dot, it cannot be changed. P1 sat, the function of temperature. You can give initial case 96.9 also, no problem, if you want. You give initial case 96.9. Calculate y1, calculate y2. Check summation y equals to 1 or not. If it is not, you have to change the guess. How to change? How to change it? What is your introduction function? What is your introduction function? Don't mug up. Again I am saying, if you talk in terms of equation, the problem, think what is my objective? What I am trying to satisfy. If you start talking about equation, that's it. You have to, that's what I am saying, you have to feel thermodynamics from your heart. What I am doing here? What is my objective? Objectivity. I can tell equations, no problem. I can also tell equations. You are talking some equations. I don't know what equations you are talking about. What equations? Can you tell me once again? Newton Raphson is anything, right? But how do you implement here? Any idea? What you want to do? What is your objective? Check. Check PSAT. PSAT is what you are talking about. What's your objective? What you are verifying? Yes, summation y equals to 1. So what's the equation? Summation yi minus 1 equals to 0. Right? And what is this? y1 is what? x1 gamma 1 p1 sat temperature by p minus 1 equals to 0 plus x2 gamma 2 p2 sat temperature by T minus 1 equals to 0, and this is the function of temperature. That's what I want. Don't say sum of the integration method, because you just see what you want. Just see what you want. Okay, and then we have all the equations. Now you have seen the function of ft equals to x1 gamma 1, which is a theoretical model. It's already obtained. That gamma 1 is fixed. Doesn't matter if temperature is changing or not. You got experimental values. Now from the model, the gamma 1, gamma 2 are fixed. It don't change from particular data. And this is what P1 set in terms of exponential. We have done previously, right? Similar this to exponential. You take the numerical derivative. Okay? So what you do? You have the temperature, the T old is 96.9 degrees centigrade. So T new equals to T old minus function T old divided by F prime T old. You got T new. Once you get T new, again you calculate P1 sat, P2 sat, calculate Y1, calculate Y2, verify, oh it is not matching, get the again T new, proceed further. And you will see that 96.9 degree centigrade, which was actually given, which is not correct, the actual answer is 95.01. So whatever the experimental data, 96.9, which is not correct, which will not give summation y equals to 1. Which will not give summation y equals to 1. You put initial guess, 96.9, you have to do 2-3 iterations. Do 2-3 iterations and get the final answer. I am hoping that some of you in the class will be getting at least 4 data sets with a graph, or maybe 10 data sets with a graph. If you can do it in the class, maybe next week if you can give, that will be good for me.
Is it the error with model fitting or fixed model?
What error?
Sir, we are not getting, he is just measuring from the experiment 96.9. He is measuring x1 and x1 and y1.
96.9 is the data.
Yes, sir. Data is doing for experiment.
Data is given, right? Txy 96.9. Okay? With this you calculate gamma 1, gamma 2, theoretical from the model. And then you have to calculate theoretical y1.
Sir, when you are not getting y1.
Sir, let me finish. Going to get y1, I am assuming my 96.9 is correct. It is given, the data. But thing is that theoretically I should get summation y equals to 1. I am not getting. That means temperature is not given, not correct. So I filtered it. Could I get your query?
Sir, my query is we are not getting y1 plus y2 equal to
1. Because experiment uncertainty. We could not measure temperature properly. You could not measure it properly because experiment uncertainty will be there. If you do experiments, you won't get. Actually, you should get straight line. But experiment data is giving like this. Why? I don't know. Lot of errors will be there. Sometimes instrumental error will be there. Process, some kind of loss will be there. You are not measuring. But somehow approximately you can actually get it. So like,
if I assume my experiment is correct.
no, you cannot assume. Impossible. If the experiment is correct, then why I am doing modeling? If the experiment is correct, then model prediction, if you look at the data, it should be on the straight line. It is not. So your experiment is correct or wrong, your data should tell. If all data is on a straight line, then you can say yes, my experiment data is correct. In that case, automatically your temperature is satisfied. It is physics. If your experiment is correct, 96.9 will automatically satisfied. The summation y equals to 1.
So then from the experimental plot only we can know that whether the data printing is correct or not, or the temperature is correct or not. Then we don't have to go to this summation of y and
How will you get temperature?
no,
No, how will you get temperature? You are talking qualitatively. How will you get temperature? I don't believe in qualitative remark. You just say, yes sir, alternatively, I can get this way approach. Tell me how to get exact value of temperature. I understand your queries. I am getting this type of data. I did the fit. Now tell me how to get temperature, proper temperature.
So from here you will be getting y1 is equal to x1 p1 gamma 1 x1 p1 set by p. From there what we will be doing is temperature.
Okay.
Then sir we will be satisfying the equation summation of y equal to 1 if this happening or not. If it is coming or not. After that.
No, after that, if it is not coming, then what I will do? I have that equation, and I will directly take the actual equation, my mathematical form, and do the rigorous approach. please do at home. I cannot do in the class because I have to teach chemical reaction equilibrium. Yes, you can do. This is a problem. I can give the problem that try all the models. You can do that. This is your research problem. I'm introducing research. If you want to do research, I guess you won't be doing thermodynamics research. In that case, forget it. Right? If you do thermodynamics research, then I can tell you. If I am just introducing research, I don't know how many of you guys will be doing thermodynamics research. If you are really interested, I can talk to you for hours. Otherwise, leave it. You should know the problem, how to solve, and get the marks. Why unless you take into that? Because there are many things to be done in life. So since you won't be taking up thermodynamics research, that's it. There are so many things can be done in this, but we don't have to know. Okay, that's my answer for now. Because next I will be talking chemical reaction equilibrium. I can use any model. I can use Van der Waals suffix. I can use Wooll's equation. I can use an RTL model. I can use even unique quark unifact for this. Okay, that you can try it out. Even you use unique quark unifact, what will happen? I will not tell that. This is a research topic. If you are really interested in research, you give me the solution. I can help you. And if it is good, you can write a paper. I always believe in writing papers with some good ideas. Okay. Anything else? So that is the way you can actually calculate the temperature for all this. Okay. So that's the way actually these things have been done for this. So please finish the calculation part. Next we will be going to the azeotropic system. Azeotropic system. For azeotropic system, you might have seen this, right? You should be touching. At this point, what actually happens? Constant what? One equation I wanted, that's all. So many things, please don't tell. What actually is what? PSY diagram, right? That means x1 equals to y1. That means x1 equals to y1. Okay. And for azeotrope, it can be shown that dou p dou x1 equals to 0 for azeotrope. It can be shown that. But remember that for azeotrope x1 equals to y1. The problem is, I think the last problem in the assignment sheet. Chloroform and methanol forms an azeotrope, 760 torr, 530, 53.5 degrees centigrade, and x1 equals to 0.6. Using the Van der Waals model again, calculate gradient at 53.5 degrees centigrade. So from this, you can calculate the P1 sat and P2 sat, and P1 sat will be, you can calculate 586.9 hector, and which is, another one is 484.05 torr pressure. Gamma 1 will be what? Gamma 1 will be what? Actually, the question is, in the Van der Waals model, calculate very data at 53.5 degrees centigrade. You have to have XY data. You have to have XY data, theoretical model. You have to have XY data. What is gamma 1? How much will be gamma 1 for the azeotrope? P1 by P1 sat. How much is that? P1 by P1 sat. Because gamma 1 is what? Y1P equals to x1 gamma 1 P1 sat. Y1 and x1 will get cancelled. So it will be P1 by P1 sat gamma 1. How much it is coming? 1.2948. and gamma 2 will be 1.5701. Okay. So for the Van model, what is how to calculate A and B? A and B, how to calculate? Any formula is there for A and B in Van model? How to calculate? If you know gamma 1, gamma 2, how to calculate? In that case, you don't have to do any kind of D square. You don't have to do any kind of D square because your gamma 1, gamma 2 are known. Because x1, y1 got cancelled. So experimental uncertainty is not there in the formula. Temperature is fixed. So temperature is fixed means no experimental uncertainty because x1, y1 all are cancelled. So you can directly get A and B. What's the formula for A and B for azeotrope? Any idea? Azeotrope calculation, A and B formula. No idea. No idea? Can you get A1, A and B from azeotrope? For azeotrope? Let me write down ln gamma 1 plus x2 ln gamma 2 by x1 ln gamma 1 whole square. Did you get it? Yes or no? No. For Van der model A and B, B is ln gamma 2 1 plus x1 ln gamma 1 by x2 ln gamma 2 whole square. Did you get it? Or can you get it? You can get it, right? It's possible to get it. So that means if your gamma 1, gamma 2 are known, you can put it here and get A and B. And that means your Van der equation is actually known now. And once your Van der equation is known, for all the values of x and y, so you have to get this kind of diagram. Okay? So what you have to do, go home and try to reproduce the kind of table, what I am saying. You got A and B for the Van der. x1, gamma 1, gamma 2, P torque pressure and y1. Okay, one point you can see azeotrope will form. Generally x1 is not equals to y1 for these points. Only one point azeotrope will be formed. So you have to get the diagram. Maybe Friday if you come with the diagram from this. So you have got x1 and from this model, so if you put point 1, you can get gamma 1 value, gamma 2 value from this. Right? Van der equation. And then you get P torque pressure, you get y1. Okay? How to get P? You know that summation YIP equals to, what is that? Summation gamma I xi pi sat equals to P, right? And yi equals to gamma I xi pi sat by P. Whatever you have done. So you take point 1, point 2, point 3, say point 4, point 5, point 7, point 9 and 1. While you are finding azeotrope, you take more points. I want to see the graph. To fill, you have to fill that how the azeotrope looks like, and that itself has been done based on non-linearity. That itself has been done with non-linearity. So we will finish today, and next class I will finish up generalized procedure. If there is no approximation on the low pressure, then how to really data. Give the algorithm, there is no problem solving. You have to do a programming part, you cannot do it, and next you will go to chemical reaction. Attendance please.